Today we are going to be doing quadratic inequalities. So quadratic inequalities can be written with y less than, or y greater than, or y less than or equal to, or y greater than or equal to. Quadratic inequalities in two variables. You want to graph the parabola and either put it dashed or solid. It's dashed if it's a less than or greater than sign, and it's solid if it's a less than or equal to and a greater than or equal to. Once you have it graphed, you want to find a point on the find a point either inside the parabola or outside the parabola and test and figure out which way to shade. So let's start with an example. So the first thing you want to do is you want to look at this and know it's going to open down because A is negative. Since it's in standard form, let's find the vertex by negative B over 2A. So the x-coordinate of the vertex is negative 1. So we're going to plug that in, and we're going to remember to square the negative 1, but then multiply it by the negative that's written in the front after you've squared it. So we've got our vertex, which lies on the x-axis. So we can plot that point, and we know that the y-intercept is, what is it? That's right, it's negative 1. And then we could plug into the equation 1 and use symmetry, or we can know we're going to go over 2 and down 4 from the vertex. Now, do we make it dashed or solid? That's right, it's dashed. Now I need to find a point to test. So it doesn't matter whether the point is inside or outside. But wherever it is, if it's true, you shade there. And if it's false, you don't shade there, you shade in the other place. So I tested the point 0, 0, which we know is outside the parabola. So when we plug it in, it is a false statement. So since 0, 0 is outside and that makes it false, where do we want to shade? That's right, inside. And you've graphed example 1. Example 2 is a real-world problem, so we're going to stay in the first quadrant. So a rope is used for rappelling down a cliff that can safely support your weight in pounds. W is less than or equal to 1,490 d squared, where d is the diameter of the rope. Graph the inequality and interpret the solution. So we know that the vertex is 0, 0. And I'm just going to graph the right part of the graph. And I obviously want to rescale it a little bit. And I know it's solid. So now we're only going to shade in the first quadrant. So I'm going to find a point in the first quadrant, only in the first quadrant. So I'm going to test the point 3, 1,490. And the point 3, 1,490, I know is to the right in the first quadrant. So I'm going to test that point. And is that a true statement? You got it, it's a true statement. So that means I'm going to shade outside in the first quadrant. All values in the shaded area represent the weight that can be used to support the person rappelling. If you have any questions on this, you can ask me on Monday. Okay, moving on. Graphing systems of inequalities. You're going to graph each equation and you're going to shade where it overlaps. So the first one is dashed and the second one is solid. First one opens down, and you should be able to just look at that and know the y-intercept and the vertex are the same. So the vertex is 0, 3. And then I should be able to pretty easily graph it by going right 1, down 1, right 2, down 4. And I want to graph that dashed. Then I want to test a point, 0, 0, and it's true. So I'm going to shade inside, but I'm not going to shade yet. I'm just going to remember that the shading's on the inside because I only want to shade the overlap. The next one, I'm going to find the vertex. Negative b over 2a. So my x-coordinate of my vertex is negative 1. And the y-coordinate is negative 4. And I should be able to go from there, right 1, up 1, get my y-intercept at negative 3, and then right 2, up 4. And this one is solid. Now I'm going to test also 0, 0, because that's on the inside. And that is a true statement. So I want to shade in the inside of both. So where it overlaps is right there between them. Again, if you have any questions, we can clarify this on Monday. Or you can talk to your partner. Okay, solving quadratic inequalities. There's two methods. You can do it algebraically or graphically. If you're going to do it algebraically, you're going to want to factor. And solve as if it equaled 0, and those are what we call our boundary points. Our boundary points are 4 and negative 1. So I'm going to draw a number line, and I'm going to put open circles. And they're also called critical points. And I'm going to draw open circles because this problem is just a less than. Now I'm going to pick a point to the left of negative 1. And I'm going to test it. So I'm going to pick a point in between negative 1 and 4. Then I'm going to pick a point on the right side of 4. So if I plug in negative 1, I get a positive value. I only worried about the sign. I don't need to know that when I plug in negative 2, I get negative 6 times negative 1, which is positive 6. I just need to know that it's positive. And then when I plug in 0, I know it's negative. And when I plug in 5, I know it's positive. And so less than 0 is negative. So my answer is between negative 1 and 4. So I have to write that as an inequality. Negative 1 is less than x, which is less than negative 4. So that's how to solve it algebraically, which you will have to do on your test. Graphically, you want to draw a sketch of the graph. The best way to draw a sketch, since we already know the intercepts, you can easily figure out what your vertex is. But you don't actually need the exact value. You just need to look at it. And it's whenever y is negative, which is below the x-axis. So you can visually see it's between negative 1 and 4. So your answer is negative 1 is less than x, which is less than 4. Again, if you need more of that clarified, you can come in and see me on Monday. Okay, now we're going to do a word problem. A rectangular parking lot must have a perimeter of 440 feet and an area of at least 8,000 square feet. Describe the possible length of the parking lot. So you want to use the formula for perimeter and the formula for area. And write a quadratic inequality. Describe the possible length of the parking lot. So your perimeter is 2W plus 2L, which equals 440 feet. So you want to solve for W. So you're writing the length in terms of the width. Then the area is length times width. But I only want to have one variable in there, which is L. So I'm going to plug in place of W, what I solved for in the perimeter formula, which was negative L plus 220. And then I want to get the quadratic all solved for. I don't like a negative in front, but I'm going to deal with it. So I'm going to use the quadratic formula. A is negative 1, B is 220, and C is negative 8,000. So as you calculate the quadratic formula, you should be able to do this. Those are your two possible lengths. So if those are the two possible lengths, if you look at it graphically, the length needs to be between 45.97, is less than or equal to L, which is less than or equal to 174.03. Keep making these mistakes. I solved this by graphically instead of algebraically. And it says describe the possible lengths. So that's why I went with L. I don't have to worry about W. Therefore, the parking lot length must be between those two values. Okay, so today you're going to work on your classwork, and the answers will be up at the podium. You're going to work on your classwork 2.5, and you can check with each other. I'm sorry, it's not 2.5. I'm looking at the wrong thing here. You are working on your classwork 3.5 and 3.6, and then there's a practice 3.6. So you should work on all of those. The answers are at the podium. Get those finished, and then you can start working on your big ideas. Have a fabulous weekend, and I'll see you guys on Monday.